So this is the 2006 question 1 on numbers, and the first part of it is make a table to show how each of the hexadecimal numbers 0, 1, 2 all the way up to F can be represented as a 4-bit binary string. So what I'm going to do here first off is in red we'll have the hexadecimals, and beside them what we will do is we'll have the 4-bit binary string. So I'm going to try and sort of split up this table into 3 parts, okay? So, and that should be enough room. Okay, so first off, the hexadecimal numbers, the hexadecimal symbols: 0, 1, 2, 3, 4, 5, 6, and 7, 8, 9. Now, just watch out for this, is that we don't go into 10. The next one is A, B, C, D, E, and F. Okay. So what we're going to do now is write out the 4-bit binary equivalents. Now, I'll just start us off. 0, 0, 0, 0 is the first one. But what we're going to do now is we're just starting from the right-hand side. We will, moving left, what we'll do is actually just alternate every second. I'll just do a few up at the top there. So starting from the left hand side, we alternate from 0 to 1 every step. So 0, 1, 0, 1, and so on. So the next one here is going to be 0, next one here is going to be 1, next one here is going to be 0, 1. We'll do the same thing here. We're going to alternate now. We're looking at the second column from the left, which is this one. And what we can do here is we alternate every second step. So we have 0, 0 to start off, then 1, 1, then 0, 0, then 1, 1. Next one, we're going to alternate every fourth step. So the third from the right, we're always working from the right, not talking about the left. We're going to alternate every fourth step. So 0, 0, 0, 0. Now we're going to alternate so that's 4 zeros. Now it's time for 4 ones. 1, 1, 1, 1. And finally, and the fourth column from the right, this one here, and it's not really relevant that it's at the left hand side really. What we're going to do is alternate every 8 steps here. So we're going to have 0, 0, 0, 0, 0, 0, 0. Now just remember we're continuing on this side, so we just put down 8 zeros. So we're just going to keep up that sequence going by having 8 ones. Okay. Now, apart the previous sequences I talked about, 0, 1, 0, 1, that got replicated on this side over here. So that kept going 0, 1, 0, 1, 0, 1, and 0, 1. Likewise, the second from the right, every 2 steps, that got replicated over here as well. So 0, 0, 1, 1, 0, 0, 1, 1. And every fourth step, 0, 0, 0, 0, 1, 1, 1, 1. This side of the table over here is just a continuation of the left hand side. Anyway, that's how we could represent a 4-bit binary strings as hexadecimals as 4-bit binary strings. Now what we're going to do is actually use that now in the next part of the question, where we're going to convert. We're going to use this table to convert from binary to hexadecimal and hexadecimal to binary. And how we do that is we will use this table here. Oops. So okay, what I might do is go to the next slide here just to sort of move forward. So what I'm going to do here is the first one. Hence express the number 110, 111. Let's actually write that out. 110, 111.01. Now, this is not written in blocks of 4 in the first instance. So what I'm going to do is actually sort of group digits, or group binary digits into 4-bit binary strings. Now we actually start from the radix point. This is the radix point. In decimal numbers we call it decimal point, but here we call it radix point. And we group a 4 to the left hand side of that, and then we're going to group the next 4. but you notice there isn't 4 here. What we're going to do is actually put in 2 zeros here. So we have a 0 and a 0 here. We're also going to do it for the right hand side of the radix, and we're going to put in 2 zeros here, so it's such that we have 4s. Now what we're going to do is move back to our tables and check what this corresponds to. So it was, let's see here, we have 0, 0, 1, 1, okay. That's the first one we were looking for, so that's 3. Then we have 0, 1, 1, 1. That's 7 in hexadecimal. And 0, 1, 1, 0. 0, 1, 1, 0, that is equal to 4. Okay, so the answer is 37.4. Now don't say 37.4. Not that you're going to say that, you're going to write it down, but it's not 37.4, it's 37.4. Okay, the next one is C2.6. So what I'm going to do here is actually just collect out the C. Let's just collect up all the digits as we go. So C here is 1, 1, 0, 0. The next one we're looking for is 2, so that's this one here. 1, 0, 0, 1, 0. And then finally 6, which is that one there. 1, 0, 1, 1, 0. So just piecing them all together, we'll actually just set it up like that. C2.6 is equal to, let's write that out like in as 1, 1, 0, 0, 0, 0, 1, 0, 0.011 0. Now we can leave out that 0 at the end. Actually, first off, let's just clarify where they came from. That we found. Oops, let's undo that. That we found to be C. When we looked at the tables, that part there. That we found to be 2. And that we found to be 6. Okay. Now, we can lock out that 0 at the end there as well. So that's the answer to C2.6. So express the binary number in hexadecimal and express the hexadecimal number in binary. So those are the two answers there. So what I'm going to do now is go on to part B here. And this is a good bit of work here, and so what I might do is actually save it for the next presentation. So I'll end this presentation here and we'll move on to the next presentation shortly.